Hello, this video is going to begin covering chapter 21. This begins on page 324 in your textbook if you're wanting to follow along. So chapter 21 is going to get into parenteral calculations. Parenteral basically just meaning, anything that's being injected. So IVs, any syringes, things like that, that we are injecting into the patient that is considered the parenteral route. Let's get started. Again, this is beginning on page 324 in your textbook. We're going to start by looking at basic dimensional analysis, and then we will build up to some of the parenteral calculations. So with basic dimensional analysis, we're going to use this type of calculation for calculating sterile product and flow rates, along with using our ratios and proportions. This is a math-based tool that combines different units such as hours, milligrams, liters, or even centimeters to solve a specific problem. So we have some simple problems that would include things like the number of seconds in a year and the number of millimeters in a mile. Those are just examples of simple, basic dimensional analysis equations. So we're given a sample problem here for us to begin looking at. What are we talking about when we talk about basic dimensional analysis? So our sample problem says, how many hours are there in 6 days? Well, we know that there's 24 hours in one day, correct? And we can write there are 24 hours for one day. One of these three ways that are detailed here on this PowerPoint slide. 24 hours equals one day. We could put one day over 24 hours. We could also put 24 hours over one day. Three ways to express the same thing. So how do we begin working the equation? So again, how many hours are there in 6 days? So you're going to start with what you have, 6 days. So you can see here on the PowerPoint slide that they have entered 6 days equals. They have 6 days over 1, because anything over 1 is going to be still that whole number. We do that to establish what we are starting with, our starting point. And then that is going to be multiplied by the number of hours per day. Now they have very specifically made sure to list hours above day, because once you set up a basic dimensional analysis problem, the very next thing you do is cancel out like units and numbers. So you can see in the next step beneath that notation that they have drawn a line through days where it was beside 6 days. They've also drawn a line and canceled out day where it was underneath the 24 hours. So that was why that was intentionally written as 24 hours over the one day, so that when we go to cancel out our like units, we could cancel out days, because the question asked how many hours are in 6 days. So you need your answer to come out in hours. And in this case, we have 1 and 1 listed as the denominator on both fractions. And it does say that after we set up the problem, we cancel out like units and or numbers, but those numbers would have to be diagonal. So I cannot cancel out the 1 that is listed in the denominator for each fraction, because they are not set diagonal from each other. If I had a 1 in a numerator position, then I would be able to cancel the 1 from the denominator position with the 1 from the numerator position. And we will look at an example of that a little bit later. So you're left with basically, and remember, when you're multiplying two fractions, we're going to multiply the numerator times the numerator. Numerator is your top number, and then you will multiply the denominator, or your bottom number, times the denominator. So then we can just simply work the math here. 6 times 24 equals 144, as it states below. 1 times 1 equals 1. Any number expressed as a fraction over 1 is going to be that whole number. So your answer is simply the 144 hours. So let's look at an example that's not detailed in the text. That was example 21.1 that was detailed there on the PowerPoint slides. Let me stop the screen share here, and we will look at example 21.2. Just so you can see how it unfolds on the screen. So example 21.2 gives us this question. How many minutes are in 5 hours? So again, we're going to start out with what we have. And that is 5 hours. We're going to set that over 1 because that's what we're starting with. And it's asking for minutes. And we know that we have how many minutes per 1 hour? There are 60 minutes per 1 hour. Now, the very next thing I do is cancel out my like units. So I lose my hour and I lose my hour. What I was trying to state earlier, I can't cancel these ones because again, they're both in the denominator. If this numerator was a 1, then I could cancel it out. Or if this numerator was a 1, then I could cancel it out. But that's not the case. And I believe it's probably gonna be on a different video when we finally get to the example where I can show you canceling out numbers. But you see the unit of measure that we're going to be left with here after we've done our cancellations is minutes. And that's what we're looking for, right? How many minutes in 5 hours? So then again, when we are multiplying fractions, we're just going to multiply numerator by numerator, and that's our top number. So 5 times 60 equals 300, right? 1 times 1 equals 1. Anything over 1 is understood to be that whole number. So we have 300 minutes in 5 hours. That would be the answer to that equation. Let's do one more. We'll look at example 21.3. So example 21.3 poses the question, how many seconds are in 45 minutes? So again, we're starting with 45 minutes. So I'm going to set that over 1. My question's asking me about seconds. So how many seconds are in 1 minute? $60 seconds per 1 minute, correct? Now I've got my equation set up. I'm going to cancel out my like units. I don't have any like numbers that I can cancel out. So I'm left with 45 times 60 over 1 times 1. So we already know that this is going to come out to be a whole number. 45 times 60 comes to 2,700 seconds. That's 2,700 seconds. Or the 1 times 1 is just going to make 1, and any number expressed over 1 is just that whole number. That was the only reason why I skipped multiplying those. If you need to go ahead and multiply these and put it here and then rewrite your answer without it being a fraction, that's completely fine, whatever works for you. I'm just simply skipping this step because I know 1 times 1 is going to give me 1, and anything over 1 is going to be that whole number. So I just multiplied my top numbers and saved myself a step. I know we said that was going to be the last example, but let's go ahead and look at example 21.4. Example 21.4 on page 325 of the textbook poses the question, how many seconds are in 3 hours? So once again, we're starting with what we have, which is our 3 hours. And I'm going to set that over 1. I'm trying to get to seconds. I can't go straight 2 seconds though. So let's look at what's the next increment down from hours. It's going to be minutes, right? So we know that for every 1 hour, and I'm writing that there because remember I need to be able to cancel out my unit. For every 1 hour, I have 60 minutes, right? I've got to get to seconds though. So for every 1 minute, And again, I'm writing that notation here so I can cancel out that like unit. And I have 60 seconds for every 1 minute. Then we could go ahead and cancel out our like units. Hours can cancel and our minutes can cancel and any like numbers. In this particular example, although we have the 60 and the 60, they're not set diagonal from one another, so we cannot cancel that out. Same thing with these ones. We can't cancel those out because they're not diagonal from one another. They're linear. So then we know already that 1 times 1 times 1 is going to equal 1. And that's my denominator, and anything listed, any numerator listed over 1 as the denominator is just going to in fact be that whole number. So once again, I really only need to look at my numerators. So we've got 3 times 60 times 60. That equals 10,800 seconds that are in 3 hours. And we'll go ahead and do example 21.5 as well, because you've got to get this concept down before you can do the math in other places. Okay, so example 21.5 poses the question of how many seconds are in 4 days. So this time we're starting with days. So again, I'm going to put what I have or what I'm starting with, 4 days, and I'm going to set that over 1. I'm trying to get to seconds. So if I'm at days, what is my next increment down? Oops, I'm sorry. Hours is going to be your next increment down. And we know we have 24 hours per 1 day. 24 hours per 1 day. I've still got to get to seconds. My next increment down is going to be minutes, correct? So we went from days to hours. Now we're going to go to minutes. We've got 60 minutes for every 1 hour, correct? Still got to get to seconds. And we know we have 60 seconds for every 1 minute. Now I've made it all the way to seconds. So let's go ahead now that we have our equation set up. We're going to cancel out our like units. Days are diagonal, so I can cancel those. My hours, they're diagonal, I can cancel those. And I can cancel out my minutes because they are diagonal from one another. So you see, it's very important to watch how you're setting your equation up so that you can cancel your units out accordingly. And the only unit of measure left is seconds, which is what we are looking for. How many seconds in 4 days? So again, my denominators are 1 times 1 times 1 times 1, which is going to equal 1. So I know that my numerator is going to be a whole number, which leaves me with 4 times 24 times 60 times 60. Gives me 345,600 seconds. That is how many seconds are in 4 days. So I hope this has helped you get the initial concept down from chapter 21, because you'll find as we move through chapter 1, we're just going to keep building and building and building on the concepts that we master. So that was it for this video installment, and I will see you again in the next video. As always, please reach out if you feel like you didn't fully understand something, you still have questions. I don't know my help is needed if you don't let me know that it's needed, and that's what I'm here for. So just give me a holler if you feel like you still need me. So until we meet again, bye-bye for now.